So this video is to help you get through exercise 19.2. Now in 19.2 we meet quite a number of new terms. Well, the first thing to note is, we were seeing a second, a function is only a function if each input is only used once. Now in this exercise you meet these things called mapping diagrams. So for example, here I have an input x and the output is 2x minus 1. So what I'm going to do to every input, that means, is I'm going to multiply each input by 2 and subtract 1. So you end up with these outputs here, 1, 3, and 5 will give you the answers to if the input is 1, 2, and 3. This is not a function because, as you can see, the input b is used twice. So for something to be a function, each input has to be used only once. And there's some fancy terms maybe. So the input value is generally called the x value, but a fancy name for that is the domain. The outputs that you actually use are called the range, and sometimes this notation here is used. So for example here, this is 3 ways of saying the exact same thing. The output is equal to 2 times the input plus 4, and it can be presented in each of these ways here. They all mean exactly the same thing. And then when we're finished maybe working out our outputs, we can write our work in couples. So for example, we put each input with its corresponding output. So I have 3 couples here for this function: 1, 1, 2, 3, and 3, 5. There's quite a bit of information there now, but let's go back to the exercise here, so you can reach down to that carefully if you like. So the codomain is basically the set of all possible outputs. So you can see here, the codomain here is 1, 3, 5, 7, 9, 11. But the range is the set of used outputs, so it's 1, 3, and 5. And the domain again is the set of inputs, so 1, 2, and 3. And to go back down to the exercise, what's the domain here? All these guys here. The range here and the codomain are equal because all the outputs get used up. So just list all them off. And then work out the rule here and then write down the domain and range. So add 5. So the domain here is 1, 2, 3, 4, and the range is going to be 1 plus 5 is 6, 7, 8, and 9. The rule for the second example is 2x plus 1. So it's a bit fancier. You must multiply each input by 2 and add 1. So the first output is going to be 2 times 2 is 4 plus 1 is 5. You work all those out and state your domain and range again. This one here, part 3, is certainly not a function because the input 9 is used twice. And the same here. For question 5, why is that not a function? You look carefully at the first value in each couple and you see that 2 appears twice. So therefore it's not a function. It's all quite easy, I hope. And question 7 is okay-ish, I think. Just follow the flow chart there. And again here, the range is the outputs that you've used, and the codomain is all the outputs listed off. And you can work your way down to that there, I think. Now again, for this one here maybe, the fancy notation here, you can ignore all that. All you're interested in is 3x minus 1. So you take each input, you go 3 times 1 is 3, minus 1 is 2, and do the same for 2, 4, and 6 and work them all out. And then question 16 is a toughie, but I have it here to note a bit. So for example, in question 16 here, to get the output, you multiply the input by 6 and subtract 2. So to find a here, how do we find a? Well, the input value is 2, so I put that into the function. So I do 6 multiplied by 2 is 12, minus 2 is 10. So there's the answer for a there. Now to find d is trickier because d is an input. But what we do is, the output here is minus 14, but our formula for the output is 6x minus 2. So I let this equal to minus 14, and I work out what x would be. So that means here I end up with a value of x equal to minus 2 when I work out 6x minus 2 equals 14. So my actual answer, which I should have wrote there correctly, is d equals minus 2 is the answer. So now go and try exercise 19.2 yourselves.